time with Manasa. Friends, actually my channel is all about chemistry. Through this channel, I am uploading the videos in which I am explaining different aspects and concepts of chemistry. Since second PUC or class 12 examinations are very near, I am uploading the videos which are very helpful for them. First chapter from class 12 syllabus, the solid state. From this chapter, we get different types of information about solid state. Friends, after completing this chapter, I make a video of important question from this chapter. First, let me explain the contents of the chapter. As we know, there are three states of matter, namely solid, liquid and gas. So first, let us consider characteristics of solid. Solids have definite mass, volume and shape. In the solids, the intermolecular forces are very strong, but intermolecular distances are very short. The solids are rigid and non-compressible. These are the four very important characteristics of solids. And solids are classified into two categories. First one, crystalline solid, and second one, amorphous solid. Friends, solids are classified into two categories, crystalline solids and amorphous solids. Let us consider the differences between crystalline and amorphous solids. So, important concept, you may be asked to write the differences, or from this section, any one more question may be asked. So, first difference is crystalline solids have definite characteristic geometrical shape, whereas amorphous solids have irregular shape. The crystalline solids have sharp melting point, but amorphous solids gradually soften over a range of temperature. Here, sharp melting point means the crystalline solids melt at one temperature or at one particular temperature. Crystalline solids have definite heat of fusion, but amorphous solids do not have definite heat of fusion. Or crystalline solids have high and definite heat of fusion, but amorphous solids do not have definite heat of fusion, and value is also lower as compared to crystalline solids. Here, heat of fusion means the amount of energy required to melt a unit mass of a solid at its melting point. The crystalline solids are true solids, but amorphous solids are pseudo-solids, or sometimes termed as supercooled liquid, because they have the tendency of flowing. And crystalline solids are anisotropic in nature, but amorphous solids are isotropic in nature. Here, anisotropic means for any solid, any physical property has different values when it is measured in different direction, then it is called anisotropic in nature. But the physical property has the same value when measured in different directions, then it is called isotropic in nature. The crystalline solids have long range order, amorphous solids have short range order. Here, long range order means any regular pattern of arrangement of the constituents, that means molecules or atoms, repeats itself over entire crystal, then it is called long range order. But the irregular shape or irregular arrangement of the constituents is called short range order. So example for crystalline solids, sodium chloride, quartz, cesium chloride or diamond, etc. For amorphous solid, glass, rubber, plastic or talcum powder, etc. So friends, then let us move on to next concept. The important terminologies. First one, crystal lattice. A crystalline solid has a regular arrangement of particles and they are shown by points. The regular pattern of points indicating the three-dimensional arrangement of ions, atoms or molecules is called crystal lattice. Every point in a crystal lattice is called lattice point. When these lattice points are joined by straight lines, they form entire crystal. So friends, to understand these terminologies properly, let us consider a portion of crystal lattice. Don't bother, they don't ask to draw this diagram in your examination. So just look at this diagram. As we know, the crystalline solid has a regular arrangement of particles. So the particles means they may be ions, atoms or molecules, and those particles are indicated by the points. The regular pattern of the points indicating the three-dimensional arrangement of atoms, ions or molecules in a crystalline solid is called crystal lattice. So this is a portion of any crystal lattice, and these points indicating the particles of a crystal lattice are called lattice points. When these lattice points are joined by straight line, we get entire crystal. So next, there is another terminology, that is a unit cell. The smallest possible portion of a crystal lattice, which when repeated in 3 dimensions forms the entire crystal, is called unit cell. So in this diagram, this portion, when we repeat this portion in all the direction, we get the entire crystal, and it is the smallest possible portion of this crystal. Next, parameters of unit cell. Each unit cell has 6 parameters. Actually, parameters are nothing but 3 edges and 3 angles between the edges are the parameters of unit cell. So let us consider a typical unit cell. Here, the dimensions along the 3 edges A, B and C are 3 parameters of unit cell, which may or may not be perpendicular to each other, and the angles between these edges are other 3 parameters of a unit cell. The angle between B and C is denoted by alpha, angle between A and C is beta, and angle between A and B is gamma. So the parameters of unit cell are A, B, C. The dimensions along the 3 edges of a unit cell, and alpha, beta, gamma, angles between the 3 edges of a unit cell. So A, B, C and alpha, beta, gamma are the 6 parameters of a unit cell. Friends, I hope you like this video, and this video is informative and helpful for you. For more chemistry related videos, please subscribe my channel, support me and keep watching the videos. Thank you.